the maximum P that can be applied without causing movement in crud. Now, in order to solve a problem like this, we need to make some assumptions and check to see whether that assumption is correct or not. Well, let's just examine or inspect this crud. A force is acting in this direction. Now, this force is able to slide this crud in the x direction, or it's able to tip over one of its corners, and clearly if it's going to tip over, it's going to tip over this corner. Correct? Now, by knowing that, let's first assume that it's going to slide. And in order to slide, we need to draw FBD and examine to see whether it's really sliding or it's not sliding. Your book has a configuration in which it shows you how you need to draw FBD for a case like this. Now we have P that we have to show it, that's equal to we don't know, and it's located at 4.5. So I will use another color to show 4.5. I just use red color to show the forces. Then I have this weight, which is 250, and then I'm going to have one force which is normal to the surface of this contact area. You remember from previous chapters we said that in the surface area we have a force acting perpendicular to that contact area, and we use N to show it. Also, because we assume that it's slipping, it means that a friction is acting to prevent it from slipping, but that friction is not enough. So when it says friction slipping is occurring, that means that we have applied the maximum friction that we have, but it was not enough, and that maximum friction is equal to mu n. That's the maximum friction that we produce. So we assume that a slip will occur, and we are checking to see whether this assumption is correct or not. Now, in order to have a correct, or in order to fulfill this assumption, this x needs to be between 0 and b half. This b half is this 1.5. The b is the width of this carrot. That means that if we calculate x, and x is between 0 and 1.5 feet, then it's going to slip. Now we have to now solve this and find all these unknowns. We have 1, 2, 3, and 4 unknowns. We have 3 equations of equilibrium and 1 friction equation. Therefore, we have 4 equations and we can use them. So to start with, we start with equations of equilibrium. So I use EOE, equations of equilibrium first. Now, I start with sigma Fy because I can directly find one of the unknowns from there, and that's is this n minus 250 is 0. So don't forget, fully write the equation. Some of you guys, you don't write the equations fully. N minus 250 is equal to 0 because equation is sigma F is 0. From there, I can say N is equal to 250 newtons. So I calculated, oh sorry, pound. I calculated one of the unknowns. Now I'm writing the second equation, which is sigma Fx is 0. From there, I have P acting in positive direction, F acting in negative direction is 0. That means that P is equal to F. I keep it. I will come back and write it later. Now, the third equation, before moving to the third equations of equilibrium, I'm going to use friction equation. That friction equation is mu times n, because I have already calculated n. Don't forget, it says that we assume that it's slipping. That means that we have applied the full or the whole friction, and the whole friction from that diagram that you have seen in the class, it's mu times n. So mu is zero point 0.4 times n is 250. Therefore, F is 100 pounds. So now that F is 100 pounds, from there we can see P is also 100. Now I'm going to write the third equation of equilibrium, which is sigma m, and I'm going to take moment about O, which is this point, and by taking moment about O, I'm going to find x and check x with this condition. Now, sigma m about O is again 0. So this was my first equation. This was my second equation. This is third equation, and this is equation 4, and we have 4 unknowns. So sigma m about O is 0. That means that if we assume that this is our positive direction, right hand, that means that negative p times 4.5 feet, because p is acting in the opposite direction, plus n, which we calculated and it's 250, times x is 0. From there, x is equal to, so this p is 100. It's going to be 450 divided to 250. Don't forget, it's positive, because when it goes to the other side of equal, it becomes positive. And that's equal to 1.8 feet. 1.48 is not within this distances that we assume. Therefore, the condition is not passed. So condition is not passed. This is larger than 1.5. That means that it's not going to slip. So no slipping will occur. Now that we know slipping is not occurring, we need to check to see whether tipping over will occur or not. So in order to find tipping over, again, your book says that you need now to draw a new free body diagram, and that new free body diagram is, like I said, because tipping over is occur about this point, this corner, that means that we should move the reactions and also friction to this point. So we need to move friction as well as that reaction to this point, because it's going to tip over this point. So we have F, we have N, we have P, which is 4.5, and P is, we don't know yet, and we have 215 here. Again, we are going to use equations of equilibrium to find some of the unknowns, but this time we don't know whether friction is exactly mu times n or not, because it's assuming that it's going to tip over. Okay, so it's tipping happening. So we don't know whether it's going to be equal, F is equal to mu n or not. We will check it. So again, equations of equilibrium. So sigma f x is 0. From there, we say that P minus F is 0. Again, P is equal to F. Let's keep it. Sigma Fy is 0. Again, from there, we can say N is equal to 250 pounds. So we calculated one of the unknowns. Let's this time take moment because we know the distance, we know x. X is to 1.5 because it's in the middle. So this is 1.5. So let's take sigma m about O, and from there we can find P. So sigma m about O, this is point O. That's going to be P, and this is my positive direction again. Negative P times the distance is 4.5 again, and positive N, which is 250, times the distance, which is 1.5. That's it. It's going to be equal to 0. From there, P is equal 83.3. It's going to be 250 times 1.5 divided to 4.5. So this is our P, and from here we said that P is equal to F. Therefore, F also is going to be equal to 83.3. Now, let's say how much is maximum F. So maximum F is again mu S n, which we calculated, and that's 100. That means that this F is smaller than Fs, because F that we need, we calculated, is 83, and that means that it's going to tip over, because this assumption's condition was if F is smaller than Fs, then it will tip over.